We're going to do distance today, and we're going to compare it to the Pythagorean theorem. So we start with the title of on our journal is distance, and we're going to draw a small graph, maybe, I don't know, a quarter of your paper. We're going to plot points A at 3, -2, and B at -2, -4. On the day of a test, you would see the questions as, what is the distance between points A and B? Or, what is the length of segment AB? Left off a question mark. Or, what is AB? Remember, no segment mark on top means length of. So I'm going to take my journal page and I'm going to just fold it in lightly, like that. I'm then going to draw a line roughly down the center of the paper. And I'm going to title one side Pythagorean theorem and the other side distance. For the length of room I need, I'm going to use distance on my bigger side. So I'm just going to start with Pythagorean theorem. Pythagorean theorem, if you remember, is given by the formula a squared plus b squared equals c squared. A and B are the legs of a triangle, and C is considered the hypotenuse, the longest side. If you look up at our segment, you'll notice that we don't have a triangle, but we could add in the legs. I'm doing so in a different color marker, and it becomes a right triangle. So A is going to be 2 squared plus 1, 2, 3, 4, 5. Then I have 5 squared equals c squared. This becomes 4 plus 25, which equals c squared. 29 equals c squared. C squared is not what I'm looking for. I'm looking for c. So to do that, I'm going to square root both sides. So I have c equals the square root of 29. I would check to see if I could simplify, which I can't, but I definitely don't change it to decimal. This is the most exact answer, and this is what we would be looking for on a test. Remember, we're not using decimals unless specified. No decimals, they're not exact. Now, distance formula is going to be our other column, and our goal is to see how these two things compare. So on the distance formula, we're going to start with a d for distance equals the square root of x subscript 2 minus x subscript 1 squared plus y sub 2 minus y sub 1 squared. Please note that these are minus signs here and here, and there is a plus here. This tends to cause some problems for students on tests. Please don't mix those up. To get the x2 and x sub 1, let's make a little chart over here. Here's x, here's y, here's a and b. I have 3, -2, -2, 4. I'm going to circle the x's so I don't mix them up. And I also want to make sure, oops, I missed a point, sorry, -2, -4 there. It doesn't matter which is the second point and which is the first, as long as you are consistent. So I'm actually going to use this as my point 2, just because it's on top. So the length of AB equals the square root, notice I have a long sign, parentheses, 3 minus -2 squared plus y sub 2 is -2 minus a -4. I look at my problem, I notice that I have minus negatives, so those become positive signs. So the length of AB will be equal to the square root of 5 squared plus 2 squared. Now notice these numbers here are right here. In fact, if I had square rooted both sides here, I now have the same formula. AB equals 25 plus 4. Again, here's my 25, here's my 4. The length of AB equals the square root of 29. No decimals, it can't be reduced, and there is my final answer. Hopefully you can see how Pythagorean theorem and distance are really the same thing. We just use Pythagorean theorem when we have right triangles, and we're not given points. But you always have a chance with distance formula. It's important that if you're able to graph on a test and you haven't been told otherwise, use something straightforward like this, just Pythagorean theorem. But if you don't have a graph, don't make one. Just use your distance formula. All right, good luck.